All right, guys, we're going to be talking about section 6.3 today, which is polar coordinates. So there's some notes that you can download. What we're looking at with polar coordinates, it is basically a ray. So here we have a ray in the polar axis. The endpoint is called the pole, and the point P is a polar coordinate. So it's represented by the coordinate r, comma, theta. So r is going to represent how far away from the axis it is, the distance from the pole, and theta is the angle from the polar axis. So I've given you some graph paper that you can download, but here's an example of some of it. So you'll notice that my graph is incremented by 15. So 15, 30, 45, 60, 75, 90, and these are in degrees, or they could be in radians. You'll notice that also our axis is labeled as 2, 4, 6. So that means we've got 1, 2, 3, 4, 5, and 6. And then we have the negatives also. So if I have a point 3, 30, that's a polar coordinate. That means that I'm going to start at 0, I'm going to go out 3, and then I'm going to go to the 30-degree mark. And so my point 330 would be right here, and that's point A. 5, 240. So that means I go out 5, and then I go around, staying on the 5th line until I hit the 240 mark, which is right here. So that's point B. 1, 135. So I go over to the 1, and then I go around, staying on the 1 line to the 135, and that's right here. So that's C. You see that? Okay, negative 245. So negative 245 means I'm going to go negative 2, and then from here, I'm going to rotate 45 degrees. So that means that that's going to put me right here, at this point right here. So that's D. 4 and then 5 pi over 4. So we're going to go out 4 and then 5 pi over 4. So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. But I only want to be on the 4th ray out. So right here, and that's point E. So negative 4 pi over 4, negative 4, and then pi over 4. This is the same point, so it's actually point F also. Negative 4, 5 pi over 4, negative 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, and I'm at negative 4, so that would be right here. And then 3, 390, so 3 is right here. And then 390 is going to be all the way around. That's 360. And then 30 more would be right here. That's 390. So that's H. Now, there are a couple things I want to point out to you here. So notice that E and F are the same points. So these two are the same points. So if I have 4, 5 pi over 4, that means I went out 4 and I went all the way around to 5 pi over 4. Well, another way of thinking about it is that I could have gone to pi over 4, and then I could have gone backwards 4. So if you think about this one, I'm rotating to pi over 4, and then instead of going a positive direction to pi over 4, I'm going in a negative direction to negative pi over 4. So that's a way to think about it. We're going to talk about that more down here. Also, G. Notice that G is negative 4, 5 pi over 4. So again, imagine I rotated all the way around to 5 pi over 4, and then I went backwards 4 places. So there's a couple ways you can think about these graphs. But what we're looking at is typically we move to the distance first. So we're going to do the 4 first, which is the R value, and then we're going to rotate. That's one way of looking at it. So this next section, what they're asking you to do is give 3 other coordinates that represent the same point. So negative 150. So we're going to do this by adding 360 and adding 180 and subtracting 360 and subtracting 180. So when I add 360 to this, I get 510. When I subtract 360 from this, I get negative 210. When I subtract 360, I said that right, I get negative 210. So when I add 180, let me make sure I'm doing my numbers right. Okay, so we have 150 plus 360, that gives us 510. And then 150 minus 360 gives us negative 210. I said that right? And then we have, I think I left off my negative sign here. That's what I'm sorry. Okay. And then we're going to take the 150 plus 180 and we get the 330, and we're going to do 150 minus 180, and that's where we get the negative 30. So here's why I hesitated. I'm supposed to have a negative here. So let's look at these points on our graph. So negative 2, positive 150. So positive 150 would be like right here. Whoops, right here. It was 2. Okay, so that's that point right there. So positive 2, positive 230. So positive 2 all the way around to 230 is the same point. Negative 2, 510. So negative 2, and then 510 would be 360 plus another 150. So I'm right back there again. Negative 2, negative 210. Negative 2, negative 210. So, oh, I'm sorry. Negative 2, negative 210. Sorry, went the wrong way. Would be right there. So all of these points represent the same red dot right here on my graph. It's just moving in different directions. Okay, so we're going to do the same thing here. We added 360 and I got 300. We subtracted, added 180 and we got 120. We subtracted 360 and we got negative 420. And I didn't do the one extra where I subtracted 180 because I'm only asking for 3 points. So these are my 3 different ones. So again, let's look at it again. So positive 5 and negative 60 would put me down here. Oops, right here, sorry. And then negative 5 and 120. It's 120 rotation. And then positive 5 and negative 420. So negative 360 plus that extra. So those are just different ways to represent the same points. All right, we can also do it with radian measures. We're going to do the exact same thing. We're going to add 2 pi, add pi, subtract 2 pi, and subtract pi. So what I want you to notice here is that when I'm adding 360 or subtracting 360, when I'm adding or subtracting 360, my R value stays the same. So R stays the same with 360. And let me clarify that same sign. So when I added 360 to this and I got 510, it's still negative 2. When I subtracted 360 from this and got negative 210, it's still negative 2. But when I deal with the 180, I'm going from here to here. So that means that my R value is going to change signs. Same thing down here. R is going to stay the same sign. With the 2 pi. So again, I'm adding 2 pi or subtracting 2 pi and getting the same values. Hopefully that makes sense to you. Those are some of the answers that you can look at there and check those numbers. Okay, so then some more information about polar coordinates, oops, on the back. So what we're doing here is we're converting our polar coordinates to rectangular coordinates. So I want to be able to represent them in terms of an x and a y value on the axis as opposed to the polar axis. So the numbers that you see here at the top, or I'm sorry, not the numbers, the formulas that you see here at the top, x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent of theta equals y divided by x. We're going to use all of those concepts for these problems. So let's look at those problems. Here's our first one. So I have the polar coordinate 3 pi. 3 is the r value, pi is the theta value. So I know, according to this, that x equals r cosine theta and y equals r sine theta. So if this is r, I'm going to put this in for r. And if this is theta, I'm going to put in for theta. So I get x equals r cosine theta, which is x equals 3 cosine theta. Y equals r sine theta, so y equals 3 sine theta. Well, cosine theta, using my unit circle, is -1. So this becomes 3 times -1, so x equals -3. Y equals r sine theta, y equals r times sine times pi. So sine at pi is 0, so 3 times 0 is 0. So if I think about this, 3 and pi, going back to our unit circle, means that I went out 3 and around pi. So I ended up right here. And that coordinate on a coordinate plane would be the coordinate -3, 0. So when I look at what I got here, I got x equals, whoops, sorry, I don't know how long it's been out of focus. I wasn't paying attention. So x equals -3 and y equals 0, which is the ordered pair -3, 0. So let me go back and explain that again because I just realized focus was out. So the point -3 pi means I went, 3 pi means I went to 3 and then I went around to pi. So I ended up over here, which on a coordinate, on an x and y coordinate system would be the point -3, 0. And again, that's what I ended up with here for my rectangular value. Okay, so let's try the next example. I've got -10 and pi over 6. So we're going to do the same two formulas. R is -10, pi over 6 is theta. So cosine at pi over 6 is square root of 3 over 2. Sine at pi over 6 is 1/2. So I get -10 times this, -10 times this, which is -5, and -5 square root of 3. So my x coordinate is -5 square root of 3, and my y coordinate is -5. That's my rectangular coordinate. Okay, next one. So we have 3 and pi over 2. So same thing, put 3 in. Put 3 in here, pi over 2. Cosine at pi over 2 is 0. Sine at pi over 2 is 1. So I end up with x equals 0 and y equals 3. So that's my rectangular value. And here's our last example, D. And we end up with the ordered pair square root of 2 over 2, square root of 2 over 2. All right, so our third part, our next part is we're converting from rectangular coordinates to polar coordinates. So we have some rules here. So converting from a point to a rectangular to polar coordinates, r has to be greater than 0. Theta has to be a positive number between 0 and 2 pi. So we're going to plot the point, and then we're going to find pi by doing Pythagorean theorem, x squared plus y squared. Remember, distance is always positive, so I'll always get a positive value for r. And then we're going to get theta by doing tangent of theta equals y over x, and then figuring out where theta is. And we have to remember that it has to be passing through xy, so we have to think about our quadrants here. Okay, so let's look at these examples. All right, so our first example, we have the ordered pair -3, which is in quadrant 3. So our first step is we're going to do this Pythagorean theorem to figure out r. So this is x, because remember we're in rectangular and we're trying to go to polar. This is x and this is y, so x squared plus y squared. So we get square root of 18 is r, which is the same thing as 3 square root of 2. Then we need to know what theta is. So tangent of theta is y over x. So it's going to be -3 over -3, which is 1. So where is tangent equal to 1? At pi over 4, right? But we're in quadrant 3 because the ordered pair -3 is over in is over here in quadrant 3, right? Oops. Okay, we're over here in quadrant 3, right? So we need to figure out what is the equivalent to pi over 4 in quadrant 3, and the answer is 5 pi over 4. So my answer in polar coordinates is r is 3 square roots of 2, and theta is 5 pi over 4. Let's look at the next one. So -6, is on the x-axis. So we're going to do r, which is x squared plus y squared. So we get 36, square root of 36, which is 6. And then theta is 0 over -6, which is 0. So tangent is 0 at 0 degrees. So our polar coordinate is r equals 6 and theta equals 0 degrees. Next one. So we have 4 and 4, -4 square roots of 3. So we're going to do our Pythagorean theorem. X squared plus y squared, which is 64. So r is 8. So now tangent of theta is y over x. So -4 square roots of 3 over 4, which that reduces to negative square root of 3. So where is tangent square root of 3? It's square root of 3 at pi over 3, right? But we need a number in quadrant 4 that's equivalent to that. So the equivalent in quadrant 4 is 5 pi over 3. So our ordered pairs are 8 and 5 pi over 3. Another one. -3, 4 is in quadrant 2. So r equals Pythagorean theorem, x squared plus y squared, which is 5. Theta is 4 over -3. So we have to use our calculator this time. We do second inverse or second tan, and we're going to come up with theta is -53.13. But this is in quadrant 2, right? So I have to get a point in quadrant 2. So -53 is right here, right? Here's -53. I need a point in quadrant 2. So quadrant 2 is 180 degrees more. So I have to add 180 to that to get me into quadrant 2. So that's the 126.87. So my ordered pair is r equals 5 and theta is 126.87 degrees. All right, everything doing all right so far, I hope. Okay. Our last part is converting the following rectangular equations into polar equations that are expressed in terms of theta. So we're going to do it one more time. We're using these formulas. X equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. So we're taking our problem. This is what we're given, 3x minus y equals 6. And we're replacing the x's with r cosine theta. And we're replacing the y's with r sine theta. So we end up with this. So we want to solve for r. So that means I need to factor out the r. So factored it out, and I'm left with 3 cosine minus sine equals 6. And I want to solve for r, so I'm going to take all of this and divide both sides by it. So my final answer is 6 divided by 3 cosine theta minus sine theta. And that's my answer. Okay, so the next one, I have y equals 4. That's a linear equation. I'm replacing y with r sine theta equals the 4. And then I want to solve for r, so I'm dividing both sides by sine, and that's my final answer. Okay, the next one, I have x squared plus y plus 1 squared equals 1. So remember, this is the formula for a circle. Okay, anytime you have x squared plus y squared equals something, that's a formula for a circle. So I have a circle here with this, or a center at 0, -1. So let's go through the problem. So I'm replacing x with r cosine theta, but it's x squared. So I have to put a squared here. And I'm replacing y with r sine theta plus the 1, and that's all squared. And then there's the equal 1 on the end. When I square this, I get r squared and I get cosine squared. To square this, I have to FOIL it out. Okay, so remember to FOIL. It's going to look like this. So that's going to be r squared sine squared, r sine theta, which is 2r sine thetas, and 1, and again equals to 1. So if I look at this part right here, I can factor out an r squared, and I'm left with cosine squared plus sine squared. That's a Pythagorean theorem identity. So that equals 1. This I haven't touched, so 2r sine theta plus 1 equals 1. So now all of this over here becomes just r squared plus, and I'm pulling this down right here, 2r sine theta plus 1 equals 1. So now I'm going to get rid of this 1, move it over to the other side, and I get r squared plus 2r sine theta equals 0. Factor out an r, and I'm left with r plus 2 sine theta equals 0. And I can set both of these parts equal to 0. So r equals 0 and this equals 0. But at the very beginning, back in our notes, we said r has to be greater than 0, right? So this answer here is extraneous. We throw that out. That part goes away. And then I just solve this. I move that 2 sine theta over, and then this is my answer. A little bit more work involved on that one. All right, so here's another one, D. So on D, what we're doing, again, setting y equal to r sine theta, setting x equal to r cosine theta. I moved them all to one side and factored out an r. And I ended up with r sine theta minus cosine theta. And again, I'm going to set both parts equal to 0. And I end up with this. Well, again, this is extraneous because r can't equal 0. And over here, I'm going to set those equal. So I need to know where is sine equal to the cosine. And sine and cosine are equal to at pi over 4. And they're also equal at 5 pi over 4. So those are my two solutions. So theta equals pi over 4 and 5 pi over 4. And that's all we're finding on that one. Okay. All right, we have one more. This one, the problem is x squared plus y squared equals 9. And if we go back and look again, remember I said x squared plus y squared is r squared. So I can replace this with r squared. So r squared equals 9. So r is plus or minus 3, but r always has to be a positive number. So r is just equal to 3. And that's my solution. All right, so the last part that we have is converting the polar equations to rectangular equations in terms of x and y. Let's look at these examples. So here's our first one. So we started off with r equals 4. And so what I'm going to do is I'm going to multiply each side. I'm going to square r. So I'm going to square both sides. So I'm going to end up with r squared equals 16. So I squared both sides. So when I did that, I ended up with r squared equals 16. Well, remember, r squared is x squared plus y squared. So I can replace that with x squared plus y squared equals 16. And now I have converted from polar form into rectangular form. So that's one method, squaring both sides. Our next one, we have theta equals 3 pi over 4. So the way we're going to treat this is we're going to take the tangent of both sides. So if I take the tangent of both sides, I get tangent of theta equals tangent of 3 pi over 4. Tangent of 3 pi over 4 equals negative 1. So tangent of theta equals negative 1. And tangent of theta is y over x. So I can replace tangent with y over x. And then basically cross multiply, so I get y equals negative x, and that's my rectangular form. This is also just a linear equation, correct? It's going through the, it's a negative slope going through the origin. The first one is a circle. So these are things to think about as you're going through. Okay, the next one, r equals negative 2 secant theta. Well, secant is 1 over cosine. So I can rewrite this as negative 2 over cosine. And then I'm going to cross multiply. So when I cross multiply, I get r cosine equals negative 2. And r cosine is x. So x equals negative 2. And here's my rectangular form. All right, the next one, we have r equals 10 sine theta. I'm going to multiply both sides by r like I did on, or not like I did on the first one, so it's a little bit different. So multiply both sides by r. And when I do that, I get r squared and 10 times r sine. Well, r squared is x squared plus y squared, and r sine is y, so I end up with this. Now, I am perfectly good with you stopping here, or you could stop here. And that's perfectly adequate. I don't have any problems if you do that. So I think we'll just do that. What they've done here is they've completed the square and they've ended up with an equation of a circle. But I'm okay if you stop at this point. Okay. One more. This last one. So this is the problem that we have. And again, we're multiplying by r. So I end up with r squared, and I end up with r's here. So it gets x squared plus y squared equals 8x plus 2y. And again, I'm perfectly happy if you stop here, because we've got it in rectangular form technically. And all we're doing here is completing the square and finding out some more information, which we haven't done a whole lot of that yet. Okay. I hope this helps, and let's see if you can try some problems now and get these problems on your own.